Welcome to 3DOptix tutorials. In this tutorial, we are going to start a new project and add a light source to our optical system. We will then go over the created light source options that can be selected and the parameters that can be changed. First, we will click on the Create button and select New Design. We can now name our design, and since this is a tutorial, we will simply name it Tutorial, adding a light source. We will change the scene type to lab because we get a nice virtual breadboard to work on. And since this is a tutorial, we will select the design visibility to public so that it will be available through the workshop. We will use the label dropdown to select light sources, as this is what type of design we are working on. And finally, we will put a note in the bottom stating this tutorial adds a light source to an optical system. And now we click Create Public Design so we can start on our optical system. Okay, now that we are in the design program, we need to right-click to add a light source. This is usually the first thing we need to do when starting new design, so this is our normal starting point. We will click on Add Light Source, and then a small black object will pop up on the optical table showing us where the light source is. Now let's put this light source at the origin so that when other optical components are added, we have a good global reference point. We will click on the light source, and then use the right toolbar to click Move Rotate. Then we will click Select Reference CS, which is Coordinate System, and then on the tab on the left, select GCS, which stands for Global Coordinate System. Then set the position to the origin with a Y coordinate to 100 so that the light source is above the virtual breadboard. And of course, keep all angles to 0 as well so the light source is pointing down the positive Z axis. Now back to the right toolbar, we're going to click on the light source settings. And now we can select our parameters. Currently, there are two options for the light source, a point source and a plane wave source. The plane wave source is used for lasers and directional sources, and the point source for LEDs and omnidirectional sources. Let's go ahead and select point source. The next option is the appearance of your source, which is purely cosmetic. I'll choose red for the color. Maximize the transparency, already maximized, and make the radius of the light source larger. Again, this is only cosmetic. Next, select the number of rays used for the visual layout and the actual analysis. You can select from 1 to 200 rays for the 3D layout, and between 10,000 and 1 times 10 to the 15th rays for analysis. We'll choose 100 rays for the 3D layout, and we'll keep the analysis at 1 million rays. Now, the number of analysis rays can be specified for the total number of analysis rays for all wavelengths or for each wavelength using these toggle buttons down here. Next is spatial information, where we select the source ray density pattern. We can select XY grid, circular, or random depending on how we want to analyze the light source. We'll stick with circular. Below this is the angular information options, where we can use either spherical coordinates or directional cosines to point the light source in the direction we desire. This is usually a user preference, so however you prefer to direct your light source. You can also go back to the Move Rotate option on the ribbon to direct your light source as well, using angles and positions from the GCS. Go back to light source settings. For now, we just want our light source pointing down the positive Z axis, so we won't change any of these. Next are some options for how our light source propagates. We can select half cone angle, half width, or half width at Z. This allows us to specify the correct divergence and operation of the light source we are working with. For now, we'll stay with half cone angle. Next, we need to select our desired wavelength or wavelength range. It can be either monochromatic or polychromatic. Let's choose a visible range and define the wavelengths using the edit boxes below. We can now choose the step size between wavelengths that the light source is divided into. We'll keep this at 50 nanometers. Once we're done, we hit apply, and below we can see the wavelengths that will be present in our light source. Here on the right, the weighting can be changed if the source is not spectrally flat. At the bottom, we can also manually add a wavelength to our list here in case we want to include additional ones. We'll just leave this as is for now. Finally, we can specify the power that the light source will have in watts. Change this to 10 watts. The last option is polarization, which is currently fixed to unpolarize, so nothing to change here yet. Okay, now we have added a light source and can start to build up our optical system.